Hello, and I would like to show you an example using Microsoft Excel of a business application. So let's have a look at this problem. A casino threw in a new twist. In addition to previous offers of option 1 and option 2, $30,000 5 years from now, or $25,000 today, with an interest rate that is of 3.5% annually compounded monthly. They are offering to instead give you the option of an annuity, which is option 3, $9,000 today, $4,000 each year for the next 5 years. We want to know which is going to give us the maximum amount of money after 5 years, option 1, 2, or 3. We need to calculate the value of the annuity. We need to use the Excel if statement to make the determination of which is the best option to have the most money after 5 years from the casino. The if statement should contain the Excel max function to determine which is the maximum value, option 1 or option 2, and then if the annuity is larger, we take the annuity, otherwise we just print the value that we're going to receive, which is the maximum value. Okay, so I've summarized the data down here in this table. Option 1 is to wait for the $30,000. There's no interest rate or initial value invested or payment. We just wait. Option 2 is to invest the $25,000 and to have a compound interest at an annual interest rate of 3.5%. We don't receive any regular payments. We just let the money grow over 5 years. And then option 3, we get an initial investment of $9,000. Now that's what they just initially give you. But instead, with an annuity, they pay $4,000 into an account, and then that is compounded, and then each month they pay a portion of that $4,000. So it's actually $4,000 divided by 12 is the amount paid into an account, so that it adds up to that they're paying $4,000 each year, but in monthly installments with the same interest rate. And then this is the number of times we compound per year, and then again the total number of years. So let's see how we calculated these values, and I am able to show that the best deal is to wait the 5 years for the $30,000. Now many people are a little impatient, they just want to take money earlier, but the idea is that let's show why that's the case. So for option 2, we're using the compound interest formula. A equals P times 1 plus R over N raised to the NT. A is the final amount that's in the account here, option 2. P is the initial principal balance. That's how much we initially invest in option 2. R is the interest rate. That's an annual interest rate. It's shown as a percentage. It's calculated in these formulas using decimal. N is the number of times we apply the interest per year. That's the number of compounding periods. So monthly is typically going to be 12 times per year. And then the number of time periods elapsed, that's 5 years. Now notice with the value of an annuity equation, the variables are the same, R, N, and T, except there's an additional value, and that's P, or sometimes called PMT, payment. That's the annuity that's invested. And remember, for this number, we're using $4,000, but we're actually dividing by 12 when we actually calculate this in the formula, because again, we're assuming it's $4,000 over the entire year, so each month it's 1/12 of $4,000. So I am able to show using either calculations by hand, that is these two, and just taking the $30,000 value, or by using Excel functions that are built in, that option 1 is indeed the best. So let's see what this looks like using Excel. Now we're over here at Excel and we're taking a look at the various parts of performing these calculations. So keeping in mind that option 2 is the compound interest formula and option 1 is just taking money, then option 3 is again calculating the annuity. So let's see how we calculate those. So if we just take the money, notice that we just take the value that is given in year 5. That's why I have equals to F2 here. If we perform option 2, notice that when you're actually calculating these things in Excel, I recommend you click on the formula in the top bar because it highlights the cells with color and it shows you which cells you're referring to. So, calculating this cell, that is the compound interest formula, is that formula that I showed you previously. It's the initial value times 1 plus the ratio of C3 over E3, that is the rate as a percent, but Excel automatically converts it to a decimal, divided by the number of times per year, and then we raise that to the number of times per year times the number of years. Yes, that is a cat tail in my video. Okay, so from here, let's now move on to option 3. Now, what is option 3? It's the value of the annuity. First of all, to get the full amount that you would have, we're adding B4. B4 is the initial amount. Now, the initial amount is not invested in the annuity. That's the amount they sort of give you at the beginning before putting some money into an annuity. Now, notice, how do we get this value? Well, what we first do is we take the ratio of the payment, which is $4,000 per year, divided by the number of times per year. So cell D4 divided by cell E4 gives you the payment that's monthly, and then we multiply that by that large fraction we had before, that 1 minus 1 plus r over n raised to the negative t times n over r divided by n. Now notice that you can see that's all there, okay? And it's helpful to have these colored. Also use the formula that I showed you on the previous page to refer to that, and we should get this value, okay? Notice that, again, from calculating these values, it looks like if you wait, if you're patient, you get the most money from the casino. Now here's a question. Instead of knowing those fancy formulas for compound interest or value of an annuity, what must we do using Excel functions, that is built-in Excel functions? Part of the reason Excel is so nice is that there's many built-in functions that you can use. Well, again, we stick with the same formula, just equaling to year 5 payout for option 1. For option 2, what formula are we using? Well, we're using the formula for future value, so that's FV. So let me see if I can show you what this FV formula looks like. If I do equals FV, notice that Excel here gives you various things to insert here, okay? Notice that the first thing to insert here is the rate. So the rate is the percentage rate. So I'm just going to put in some fake numbers here just so that we can highlight next one. The next one is N per. That's the number of periods. Now the number of periods is going to be the number of times you compound per year times the number of years. And then PMT is the payment, how much you pay into the investment. Okay? Now this PV and type are some things that are optional. That's part of the reason they're in brackets. So let's see how I set up this future value equation. So this future value equation was set up as C3 divided by E3 because that is the annual percentage rate divided by the number of compounding times per year. Because if it's 3.5% per year, you have to divide by 12 to get what is the percent that we're going to add in per month as far as interest. Notice that G3 times E3, that's going to be the total number of periods. Because G3 is the number of years, and then E3 cell is the number of times we compound per year. Now notice we're leaving the next item blank. We're leaving it blank because we're not making any payments. We just made one initial payment and we just let it make money. Now notice for PV, that's the so-called present value. Notice that I did negative 25,000 because that's the opposite of this option 1 initial investment. Because if I didn't change that, it would not give me the correct value. I want to see how much the future value is if we take away this 25,000. In other words, we know that 25,000 was the initial investment. This is kind of a little bit of a trick, but just keep in mind, if you're working with this and you just want to put the money in and let it grow, you subtract out the initial amount, okay? And then again, we're not worrying about this type because we're not making some funny investment at the beginning or the end. Okay, so with that in mind, that gives us the same value as we had if we used the compound interest formula. Now how about, is there a fancy formula for the annuity? Well, the fancy formula for the annuity is going to be this PV, or this so-called present value formula. So let's examine what that formula looks like. PV, present value, okay? Again, it asks for an interest rate, a number of periods. So again, I'm just going to put in some fake numbers here, number of periods. And then this time it asks for a payment. Now this time the payment, PMT, what we called capital P in the formula for the annuity, that is going to be what is the regular payment. Remember, the regular payment here should be $4,000 divided by 12, because that's a monthly payment if we pay out $4,000 into the annuity every 1 year. Okay, so again, I'll just put a fake number in there for now. Now FV, let's go ahead and see what that is, and then again, we're not going to worry so much about the type. So let's see what I put in here. Now notice, let's just focus on this PV part for now. Notice that we've got C4 divided by E4. So C4 is the annual percentage rate. E4 is the number of times we compound per year. That's 12. We do G4 times E4. Now G4 times E4. G4 was number of years. E4 is number of times per year. That's the total number of periods. How about the payment? I mentioned this a moment ago. The payment should be D4 divided by E4. D4 is $4,000 per year we're going to pay into the annuity, and then 12 times per year, that gives us the monthly payment into the annuity. We put 0 and we put 0 for FV and for type. Okay, so we're sort of ignoring those, but we're just plugging in those values to not change anything. Now, by the way, when I calculated this annuity, the PV, for whatever reason, gave me in Excel text that was negative. That is, it gave me things that was in the red. So I'm not sure really why that is. But anyway, I took the absolute value of that, and by taking the absolute value, that made it positive, and then I added B4, which was that initial amount they give you, which again is not part of the annuity calculation. We just add that in, and we get the same value that we calculated before. Now, how do we use Excel to calculate using if and max? Well, an if statement is going to be a statement that allows you to calculate based upon if something is true or not. So the whole idea of an if statement is, if this statement that is here is true, then do this, and then if it's false, do the other thing. Okay? So let's go ahead and take a look at this if statement. Move the thing back over. Okay? So, this if statement. So if I4 is greater than the max of I2 and I3, so I4 is the value of the annuity. If that's greater than the maximum of these two, option 1 and option 2, then we want to take the annuity to the screen, to the user. If not, just display the maximum value of either I2 or I3. Well, it just displays $30,000 because that's the maximum value if you're patient and if you wait. Okay, so that's the idea. All right, all of this I have summarized on a board here. This board here summarizes what I've been saying. It summarizes what those formulas look like, either just calculating sort of by hand or using the functions. So you can take a screenshot of that, or you can copy that down or pause the video as needed. And then here's what the maximum function along with the if statement looks like. Remember, I highly recommend when you click on a formula, you look at the cells that Excel is referring to. And then here is the table just to remind you of what I was saying before, so it's all in one place. I want to thank you very much for watching this video and for taking a look at High Peak Education. Please smash that like button if you enjoy this content. Please share this content with those that you know, and subscribe to the channel and share this around your social networks to grow the channel. I appreciate that. And I look forward to seeing you in the next video.